recording. All right. Most important question of your life. Who has ever watched the Transformer movies? Raise your hand if you'd like them. Yeah, it's all right. Anybody ever seen the 1980s cartoon of Transformers? Yeah? Or Starburst? Who can make the sound of a transformer transforming? Tien. What is it, Tien? There's no announcement. It's secret. Yeah. There it is. I like to go.
Whoa, that one in the trash can?
Oh, why'd you throw your candy? Just kidding. Don't get it. Don't get it.
Mr. Pasillas should be in the
All right, bring it back, bring it back. So what we're talking about when we're saying transformations, we're talking about transforming, either moving the graph up and down, side to side, or compressing it or stretching it. That's where we're going for the next week or so here. So that sound that you hear when it's transforming, that is going to be the sound we all have to make as we're transforming this function. You ready? I'm just kidding. That went sideways. When we are moving it sideways, segue, or up and down, that specifically is a translation. You can imagine it as if it's like the words in different languages. It's the same shape. It has the same meaning in both languages. It's just shifted to a different position based on geography or whatever. So when I say translating, I'm talking about just moving it. The shape stays exactly the same. Exactly the same. The way that we're going to connect this is to look at parent functions. Parent functions are basically the most basic, the simplest form of each type of shape. This is a quadratic, but look how simple this is. It's not like our, ax squared plus bx plus c. It's just x squared. What's my a value in this? This is a quadratic. What's the a value? 1. What's my b value? 0. What's my c value? 0. So you see how it's really, really simplified. It's a real basic. All the parent functions are the most basic form you can put it in without any kind of alteration. It's not negative x, so it flips down. Nothing like that happens. So you see here, if I plug in 0 for x, what do I get for y? 0 squared is 0. That's why the vertex at 0, 0. If I'm here at 1 for x, plug in 1 there, what do you get? 1. That makes sense. Plug in negative 1 right here. Negative 1 squared is 1. You see how we're building this? 2 would be out here, and what's 2 squared? 4. You see you go up way further. Negative 2 squared would be 4. It's way up here as well. So that's how that shape is created. Okay? Now, we start with the parent function. And what we're doing with the translation, again, just moving it, shifting it up and down, shifting it side to side. So we're going to keep in mind that we're altering a parent function to make this possible. Question coming? Thought I saw your hand up. So let's look at this. This is like the clue telling us the answer to this question and what we want to put in this box here. So let's look. If I'm doing a vertical shift, what I do is I take the function f of x. And that could be any function. This function could be x squared plus 5x plus 3. That's the function. Then if we wanted to move it up some amount, I would add a k value to it. Okay. If I wanted to move it down, I would subtract a value. Okay? Okay? A horizontal shift, instead of shifting with our k value, we shift with our h value. We go into wherever there's an x. We go right here. And if I wanted to shift this to the left, right, I would plug in my new h value here, and that would allow me to see a shift to the left. Okay, if I'm shifting to the left, negative 3, I plug in negative 3 here. What would this become? X plus 3. And that's something related to what we've been studying already. So my next question, that's going to bring it all together. Keep focused right here for a moment here. What form of the quad is related to the vertical and horizontal shifts? We're going to write it here after you talk with your neighbor for about 10 seconds. Go ahead and write it here after you talk. So look at what happens with the vertical shifts here. What does this kind of remind you of? What does it somewhat remind you of? Okay, here's our three quadratics. I don't mind putting it up because most of y'all are ninjas now. So which one does it remind you of? Who can tell me? Who can raise their hand and tell me? And what? Hello? Vertex form. It has H and K. And we know that. What is our vertex when we're in vertex form? H and K. Right? So if you think about that, right? If the shift was from the parent function, good job. Parent function at 0, 0 for our vertex. If we shifted the vertex to the right 2 and up 3, we would then have our new function up here. It would look identical to the other parabola. It just was translating it over there. Okay? So the reason why this is so connected to vertex form is essentially vertex form is, right? Vertex form is if I had everybody go and plug in for a vertex of 0, 0 into vertex form and simplify it. Plug in 0, 0 to vertex form and simplify it. And we're going to see how these are connected now. So this is f of x is equal to ax minus h. All right, and what do you see when you plug in 0 here? Let's see. Or let's see, plug in 0 for x, and you'll see what happens here. No, excuse me. This is our h and k. We can plug that in. Sorry about that. Plug in your h and k over here. So we're looking at our three quads. We're just seeing what happens when we take the vertex form, which is the most helpful for this translations lesson. You plug in 0 for h. Let's see. F of x equal to some a value x minus 0 squared plus 0. What does this reduce to? Question? Sure. I like questions. All right. If we're plugging in the vertex of 0, 0, I plug it in here for h and for k. X minus 0 is x squared plus 0. We don't even have to put. So essentially, we just figured out that from vertex form, we plug in 0, 0 for our vertex, and we end up with x squared. Proving, in some ways, that if you translate it, it'd basically be like translating the graph back to where the vertex is. There's no movement. The HK is 0, 0. So if you want to think about this as we're translating where the vertex is, if it's at 0, 0, and then we have a vertex here at 5, 3, essentially we're just translating the vertex, and that same shape of the graph is just moved up and over. Okay? It's almost like because we are ninjas and we know vertex form pretty well now and where the vertex is, how to find that, there isn't much difference with this lesson, is it? In fact, I feel like you already know how to find the new vertex. You just have to be told that what you've been doing is translating it from your parent function. You see what we're doing now? One moment. The reason why I wanted to teach this and kind of piggyback it off quadratics is if you had the absolute value like this, it's going to be the same deal. You're going to if you're going to move it up, you'd add a k. If you're going to move it down, you subtract a k. If you want to move it to the right, you would add or subtract the direction there, inputting it for the h value for that. So you see that all these functions are basically the parent function just moved around. Okay. Next is going to be, instead of moving up, down, left, right, is going to be to compress it and stretch it. Okay, so make it wider or make it more narrow. And then we can also stretch it this way or compress it. That one's harder. Okay. But this, for today, I want you to feel confident because you already knew a lot about what we're talking about. But now I'll take a question. Thanks for waiting.
So for the horizontal shift, it's like the first part of the vertex form.
Mm-hmm.
But like if I wanted to say like -3, like move it to the left -3, then it would be like x plus 3.
Mm-hmm.
But then would it still be squared?
Yes. It would still be squared.
It's like f of x minus
I see.
h,
I see.
squared, but would you still square?
Got it. This is talking about generally translating. because I could have a function that's linear that doesn't have x squared, right? This process would still work for that. This is saying that what you're going to plug in for x, because usually function notation, it's like f of 3, right? F of 3, you're plugging in 3. Here instead, you're plugging in f of x minus h, and it could be any kind of function. You could do it for a function like this, 3x plus 5. And like you just said, if I wanted to shift it, negative 3, I'd write it as 3 times x minus negative 3. You see, that entire x value now has been expanded in order to accommodate the shift with the x. So the reason why this doesn't have a squared value here is because this is just for in general. If you're shifting absolute value, if you're shifting a line, if you're shifting a quadratic, if you're shifting a cubic, you're still going to do the same thing. And that's why this is without the square. I think that's really good. That helped me segue and show that you can do it for any function. Any follow-up questions for that, or that wasn't quite clear? I can try to explain that differently. No? We're good? Keep going? Okay. So let's see if this is actually kind of hard. Let's see. First question here. The shift is a shift of what key point? What key point? Tell your neighbor. The shift you can see as a shift of what key point? What is a key point? What is an important point with quadratic? So all you're doing is shifting the vertex. All right, let's see. Jack, what did you think? You're just shifting the vertex. The vertex is kind of like it's the home plate. This is the most important point. You're just moving it over, up, left, right. Diagonal would be left and up, right? Okay, so left, right, up, down. HK. Basically, you're just shifting the vertex when you are doing a translation. That's it. All right. Given our function right here, and it's going to be the same for both of them, so I'll write it again. Given f of x is equal to x squared. I'd like for you, please, to write a new equation with a shift vertically of 2 and a horizontal shift of negative 3. So we're going to address this function here. It's our parent function. How would you write your new equation with that? Two ways to think about it is use the shift kind of information and work it that way, or logically just think the vertex shifts in that way, and what would your new function be with the vertex in mind? Okay, so 2 options. Let's see. I'll give you a minute for that and check with your neighbors, double check that they're going all right. When you have negative next to each other, negative and times a negative, go ahead and redeem that and make it a what? Positive. We never have a positive or a negative next to each other. You always want to rectify that. Simplify it. All right, let's see. Everyone has f of x is equal to, what should I put in here? Well, the vertical shift. Let's do that first. Vertical shift plus 2, because that's my k value. H. That's k. That's h. So it's x minus what? Negative 3. You see it now? F of x is equal to x plus 3 squared plus 2. Right? You're waiting for it. What's different? What's different? Not much is different. We're just framing it. Something you've already done. Now we're just calling it its full name, which is a translation. Okay. It's only new because we're discussing it in relation to the parent function. It's a translation from the parent function. That's where that dialogue begins and ends. Tien has a question, but it keeps going away. It's like... There it is.
Is the vertex then just the shifts from the parent function?
Correct. Yeah. Because any point in relation to the origin is a shift from the origin. Palomo's next. I'll get Adelia.
So basically, would we memorize it as h equals horizontal?
Yeah. And you think of it, it's paired with the x value. So whatever value you input for x, you would be subtracting 2 from it. So that's shifting whatever value for x you have. You'd subtract 2 and it'd be shifting it. So that it's shifting it. So that's great insights. Adelia, what do you think?
I was just gonna ask, so the x plus 3 squared plus 2, would be the answer to the problem?
That would be the answer. Yeah, we're just having to do the new form. You know the forms. You know the vertex is just a shift from the origin, so we're good. All right, last chance to see about our mastery of this. Here's our function, same one. And go ahead and shift it vertically 4 and horizontally -1. Okay. And negatives are towards the left, so if they said shifted to the left, -3. Or if it shifted to the left 3, then you're going towards negative. It's -3 shift horizontal. Just keep in mind, they may give you it worded differently. Yes.
So if it was like a horizontal shift of 1 would equal
That's correct. Yeah. And when you put in there x minus h, you're going to end up with x minus 1. Wait. If the horizontal shift was +1, or if they said it shifted to the right 1, you're +1. It's going to be x minus 1 in the end. Okay? All right. Who feels pretty confident about this? Can tell me what they end up with? Yeah, Adnan, what do you end up with? F of x?
F of x equals x plus 1 in parentheses to the power of 2 plus 1.
Everyone got this? That's what we have, right? Any other input or questions or ways to see it maybe even easier that I'm not? No? This path of least resistance right here, I think. Okay. It will get a little bit more tricky when we have to compress and stretch these functions. But if you have this down, that's going to be much easier. Because that might be a part of it. Hey, it shifts up here, and then we are stretching it from that new vertex. Okay. Thumbs up, sideways, down for this. Pretty good, pretty good. All right, so we're going to go ahead and start on classwork. Page 135, 139. Yeah, go grab your workbook. All right, thanks for watching.